I think right where that one goes. Yeah. That one might be a little tricky to find. Yeah. Oh, but I was gonna think of the same thing. Do the same exercise with that one. No, even just forward in. No forward, like from
Can you open up the Internet Explorer and links it?
Okay. So I'll do this and then I'll open that up. Perfect. I can do that.
I just want to get it started for you.
Sure.
Michael, Mark, maybe a little.
Just the map. Did stake out to a point where it calls for it on the map with elevation and everything. Soil water separator outlet.
See, it's shown on the drawing. Bird over. Yeah, but where you got that thing is, it doesn't seem like this. On the original drawing. But I converted to the city. And it may have been changed over that time.
All right, 6:30. Today's code of conduct item of the week is maintain cleanliness and condition of vehicles and equipment. Get to wash that salt off when it gets warm. Safety news, 285 days without an injury case that resulted in days away from work. That's good. Let's keep up the momentum. Today, we're going to do a safety focus on weights of materials. So when we think about materials and weights, we can put everything that we're either lifting up or putting in a truck or on a trailer into one of three categories. It's equipment, fabricated components, and raw materials. Equipment, we can determine the weight of equipment in the operator's manual, or maybe the specifications online if we don't have ready access to the operator's manual. You can also ask the guys in our shop. They usually have a pretty good idea. Keep in mind centers of gravity when loading or rigging these things like skid steers, have a really far back center of gravity, things like the boom and how much that affects it. Fabricated components, things like precast, pipe, air handlers, trench boxes. These things may not have an operator's manual, and people may not know what your catch basin weighs. That's something that you can ask the shop, but we can still figure it out. Shop drawings are a very good, accurate way to determine the weight of a fabricated component. Keep in mind with precast that they often are a little bit off. There's a margin of error there. Bills of lading are okay. They're not always great. A lot of times the shipper will just estimate. Cut sheets are good. If you have pipe, you may not have a BOL. You may not have, there's no operator's manual. It's not going to be tagged on it, but you probably can get a cut sheet of your ductile iron pipe or your PE pipe to figure out what weight it is, and do some math and multiply that weight by the footage that you have. Again, stating here that precast is often off by a margin. So raw material is not going to be tagged. It's not going to have a tag on it like a trench box might have. You're not going to have a cut sheet for some random piece of steel that you're picking up or putting onto a trailer. So when it comes to raw material, you have to know the weight of the material. You have to know the density, and you probably have to do some math to figure out how much whatever you have weighs. So when you have something that's got a rectangular cross section, something that's square and regular in shape, you can pretty quickly figure out the volume and multiply it by the density. Some of these densities are really good things to commit to memory. Concrete, 150 pounds per cubic foot. That's a good thing to remember. Softwood, call it 40 pounds per cubic foot. Hardwood, call it 60. And what we're going to do is we've given out little laminated cards with this info in the past, and we can do that again if you guys think it'd be helpful. Just see me after, I can make them for you. We're also going to post something to the ECI app So this is all readily available for people if they wanted to reference it quickly. But if you're gonna do the math for something with a rectangular cross section, you've got to know that density and you've got to multiply it by the volume. How do you figure out volume? Volume is the amount of space something takes up. So for something with a rectangular cross section, it's gonna be length by width by height. So all the same units, you know, you gotta be feet for the most part. We'd be using feet. You don't go length in feet times width by feet times height in inches. That wouldn't work. Length by width by height, you get your volume and you multiply that volume by the density and voila, you have the weight. Definitely figure out the volume of things like cylinders and things with less regular cross sections. The math is slightly more challenging. It's not that hard. Some people learned this stuff in high school. Some people didn't. If you did and you forgot or you just didn't learn it in school, that's fine. Just ask. Any of our engineering staff would be more than happy to help you out with this. There's certainly no shame in not remembering something you learned 20 years ago in high school, because it is important. So for density, this is the cheat sheet that we printed out in the past, and this is a variation of what we're going to post up. Just a few things on here. Aluminum, 165 pounds per cubic foot. Let's look at that compared to steel. Steel is 480, so aluminum's about a third of the weight of steel. That's good to know. Hardwood, oak 62, lumber, fir, I guess I was a little off. I said 40, more like 32, about half. Softwood is about half what hardwood is. Interesting stuff and good to know. Water, 8.3 pounds per gallon. That's a good one to commit to memory too. So let's see, how much does this waste block weigh? It's 2 by 2 by 6. So first, remember, we got to find the volume, right? Length by width by height. So 6 by 2 is 12. 12 by 2 is 24. Okay, so this is 24 cubic feet times 100, and I wrote 145, 150, whatever. 3,400 pounds. Good. Now we know how many we can put on our quarry trailer for like 2. Know how many we can pick up if we've got certain size rigging. It's good to write the weights of things, especially things that we're making that are very heavy. It's good to write them on the object. I don't want you to, don't go draw on your, yeah, exactly. But if it's going to go in the ground and no one's going to see it and it's going to help you be safe and keep it in mind, that's a good thing to do. And there's sheets on most of this stuff. You got a bunch of rebar, you got a bundle of rebar. Rebar's often bundled in 2,000-pound increments, but you can just figure it out. 5 bars, a pound a foot, 7 bars, 2 pounds a foot. Little tricks like this are really good to remember. So we don't want you shooting from the hip, but if you're out in the field without a lot of resources and you can do some quick math and remember the weights of some of these things, it can really help.
That'd be a good one to have on an app too.
I agree. Yeah, we can post the rebar. This basic rebar chart's good for lots of reasons.
Yeah.
We can post that one too. We had 2 instances this year where we had a quarry trailer, 2 completely separate instances, separate projects where a quarry trailer was loaded with swamp mats. In both cases, the number of swamp mats was 5. Must be something about 5 swamp mats that just looks appropriate for a quarry trailer, but it's not. It's too much. It's way too much. Swamp mats are 4 by 16. They're about 10 inches. So let's just do that math real quick. And yeah, and that's hardwood. That's from our chart, we had about 60. Let's see if I can get the calc button up. That's about 62 pounds. So let's just say that we were pondering whether that would be excessive for a quarry trailer. We go 4 by 16. Now, again, we've got to keep feet consistent. So another good thing to commit to memory that we will post on the app too is the conversion from inches to feet. A lot of people just know that 10 inches is 0.8333 feet. But that's a good one to commit to memory too. And you can just figure that out by 10 over 12 is 0.8333. So about 3,300 pounds for a swamp mat, and that's a dry swamp mat. So if this thing's been sitting in the ground, soaking water up all summer long, it's probably going to weigh quite a bit more, caked with mud. So let's see what 5 of those weigh. That's 16,500 pounds. So that's just too much for a quarry trailer. So don't do that. And it doesn't look ridiculous. It's 5 swamp mats. It's about this high. It just doesn't look crazy, but it is. It's way too much. Steel, it's hard to figure out the cross section of an I-beam, kind of, maybe. A lot of steel has a section designation that helps you with the weight. So when we talk about H piles, HP 12 by 53, that second number, that's just the pounds per linear foot. A wide flange beam, a W14 by 48, again, that second number, that's the pounds per linear foot, 48 pounds per linear foot. Some more good things to commit to memory. A lot of the cold formed sheet piling we have is about 100, more like 105 pounds per linear foot when paired. We can put that on our cheat sheet too. Some of the newer sheeting that we've taken in Middlebury is actually a bit heavier, so use caution with that rule of thumb. Pitfalls with weights and material is, units and doing the math and the nuances there. Have somebody check your math always. It's even if it seems like a simple calc, give it to your buddy, have him check it. And outside forces, especially in the cases of rigging, you can figure out the weight of a sheet pile all day long. If it's stuck in the ground, obviously there's more than just the weight holding it down, right? There's other things going on. That's a good way to break rigging when you've got concrete or steel that might be kind of frozen to the ground. So keep that in mind especially when you're picking things up. Less relevant for loading on trailers. That's all I got.
On outside forces, I also think wind on sheet piling,
Wind's a good one too.
really push hard on the crane itself.
Yep. Yeah, but we shut down operations in driving sheets in Middlebury yesterday just for that reason. So a huge area, you can get some big forces, dangerous with gusts especially.
More questions? The other thing to look for is center of gravity. Remember where your hook is, that's where your center of gravity is going to follow. If your center of gravity of your piece is offset from the center, when you lift it, it's just going to go like that right underneath there. So all your rigging will have a different arrangement than what you think. So for announcements, PT 360 is on site on Friday the 13th, 3 to 4. Check with Alberta or Matt for an appointment. Auto insurance cards are in, so please make sure the vehicle you have or signed company vehicle has one of those cards. And for projects this week, we're profiling the Burton Island utility improvements. That's technically in St. Albans, although it's offshore of St. Albans, right? So we're contracted with Vermont Parks and Rec or Parks and Forest. I might have gotten that somewhat wrong. Then I added that in there. Brian wrote this up. So I made a couple of changes, but you see this, there's a few different phases of the project. The water line, there's 3,000 linear feet of new water line throughout the island. The water lines are drained at the end of the season, each season. So to make that work well, they have drain pits installed at different locations. So at the end of the year, they drain them and pull them out. Also included were 10 new water stands where campers get their water, where they can fill up their canteen or whatever they use now. I don't think people really have canteens, do they? That was a joke.
Get the new water bottle.
Yeah, they got it on their back or something. And so then the pump house was another part of the project. It included total equipment upgrade, and there were controls, pumps, pressure tanks, and they were replaced by our subcontractor, Chuck's Heating and Ventilating. The scope of work on that part also included demolition of the old concrete filter system, a sand filter system, and new roof on the pump house. The water intake, our directional drilling team got out there earlier in the fall, but haven't finished the 230-foot bore. We'll finish later in the spring. The sewer pump station, there was some work inside, internal work, revamping of the sewer, the rail system, pumps and controls. Then access, of course, as you'd imagine, is a big deal. They fought through high winds and waves and blistering cold temperatures. In the late fall and early winter, we accessed the island by boat. And then when the lake froze sufficiently, we built an ice road out there over the anchor ice. And then this comment also that Brian says, he strongly believe we have some of the best crews out there. And what we got here is the subcontractor. I forgot to mention this guy. His company is the Green Mountain Marine Services. He shows up in the picture anyway. And they helped assist us on bringing equipment to the island. including excavators and trucks and things. And there's a more recent picture from the Gator, or from the side-by-side, Burton Island State Park. If you haven't been to Burton Island, other than work, if you go there for like summertime recreation, it's a wonderful place. It really is. It's one of those special little places in Vermont, and I certainly hope everyone can make it there sometime. There's campsites and boat moorings and everything. So here we are doing, getting the drill out into the lake earlier in the year. And then there's some more recent picture. Again, this is some of the water line work. And this guy from Chuck's is installing these tanks, and there's some pump pads and that sort of thing in here, and new plumbing. And there's one of those areas where the campers get their water. It's not plumbed up yet, but it's you might have seen it in the third bay here, or the concrete bay. They've been fabbing these pressure treated lumber little structures. Here's our safety guy going out with Wayne to just do a visit and check the ice and so on. That's what we got there. And then from the photo archive, this is the Alpert seawall in Shelburne, on Shelburne Point. Yeah, it's a staircase with ready rock walls up there.
Spiral staircase.
It's actually a bunch of manholes that were built. I think we built that many years ago.
Yeah.
But yeah, there's a spiral staircase inside of these manhole riser sections, and get to the top deck there, and the stairs are all concrete cast in place. And actually, these were an older version too. I don't know if we installed these. Were way back. These are actually precast pipe, square precast pipe pieces standing on end. And then there was a deck board on here. And then when this work, the stairs and the wall was done, this was existing. The riser was existing. They had a problem with you can see some of the shaly type rock here along that face on Shelburne Point. It breaks down really quickly with weathering. And of course, there's a groundwater that's continually seeping out onto the face, and the freeze thaw just turns that to mush. So that whole face was to protect that. So we got, someone got paychecks. Ben has a paycheck. Sorry, not here. Thank you.
Albert T. West. No. Ray Paul. Pete Green. Huh? Well, sir, let me get messed up. Adam Piper. Andrew Piper.